All right, I'm going to go over direct variation for you just to add on to what you saw yesterday. I want to make sure you have some vocabulary here. Direct variation is a linear relationship where two variables, x and y, can be written in the form y equals k times x, where k is a non-zero constant, so some number other than 0. The constant of variation is the constant k in direct and inverse variation equations. So I've given you here, all I've done here is taken our direct variation equation and I've solved for k, isolated k. So when we are given x and y, this is how we're going to find k. And an example of constant variation, so here's our equation of direct variation, and our k in this example is 6. Here I've got a couple of graphs. And so my first graph here, this is an example of direct variation. It goes to the origin, it's a straight line, and that's our equation y equals kx that it would follow. This one here is not direct variation, and as you can see, it's got a plus b over here. That's what's bringing it up on our graph. It does not go through the origin, so that is not direct variation. I have a couple of tables I want to go over with you. And the first one here, I'm going to go over how I would determine, given a table of values, if they are direct variation. So I've got my x values and my y values, and all I would do is put those in my calculator, and I'm going to try and get this here so you can see it. All right, so I'm going to go over on these with the table, and we have k equals y over x. So my y value is my 0.95, 0.95 divided by my x value of 0.5, and I get 1.9. Then I'm going to go to the next one, 2.375 divided by 1.25, 1.9. So what we're looking for here is to see if these match all along this table. 3.8 divided by 2, 1.9. 8.55 divided by 4.5, 1.9. And then 45.6 divided by 24, 1.9. All right, so this here is an example of direct variation, and we would say yes. So let's go to the next one. Same format. We're going to do y divided by x. So 4 divided by 3, 1.3 repeating, and then 2.4 divided by 5, 0.48. So this one here, as soon as I don't have a match, I'm going to say no, this is not direct variation. Okay. Here's some practice problems here. So the first one says the value of y varies directly with x when y equals 1 and x equals 4. What is the value of y when x equals 80? So I'm taking my y over x, and I'm putting in the y and the x values that I know, so y, the 1 over 4x, and then I'm setting it equal to, I know x is 80, so that's what I put in the denominator, but I don't know y. So there's a couple different ways to do this. I'm going to show you this way because it's easy on this one. I know that I can multiply 4 times 20 to get to 80. So all I'm doing on the numerator is going 1 times 20 to get to my y value, and that's 20. The second one here, I've done a different way. And it says the value of y varies directly with x. When y equals 3.5, x equals 12. What is the value of y when x is 39? So I've set it equal to each other. And for this one here, I've cross-multiplied. And when I cross-multiply, that's 39 times 3.5, which I put here. And then I have 12 times y. I multiply 39 times 3.5, and I got 136.5. And I set it equal to 12y. And then I just used my properties, and I divided by 12 to get y by itself. And then I divide by 12 on the left side here, and I get 11.375 is equal to y. All right, my next one here is the question says amount of money varies directly with the number of hours worked. When I work 56 hours, I get paid $1,204. How much money do I make working 224 hours? So I've set my proportion up here. So my 1204 divided by 56 is equal to, we don't know how much money, over 224 hours. Again, I'm cross multiplying, which is what I've done here. When I multiply those, I get 269,696, and I bring my 56y down. I divide by 56, bring down my y, I divide by 56, and I find that it's 4,816. So I end up with $4,816 in 224 hours. All right, now I have a your turn. Given the last problem, and so I will put that back up here for you. We had $1,204 in 56 hours. How much do I make per hour? So that's what I want you to put in there for your ed puzzle. Have a great day, and if you have any questions, you can join my meeting at 1 o'clock or send me an email. Bye.